So I had some questions about problem 7.48, and the first thing to remember, right, what atoms can form ions with electron configuration of Nd5. So we're starting with metals. Metals are going to lose electrons, so we're going to have to start with neutral atoms that have more than this electron configuration, allowing us to lose a few to obtain this electron configuration. And the other thing to remember is for transition metals will form ions by losing electrons from our highest quantum level first. And that's what we need to remember when we're figuring this out. So what does that mean? Well, we'll look at a case with iron. Iron's the easiest one to look at and show you what that means exactly. So the condensed configuration for iron, neutral iron, is simply just argon 4s2 3d6. So right, it already has more than enough electrons. So certainly iron can obtain ionic configuration that has only 5d electrons available. And so what does this mean? How we're going to lose those electrons? We're going to lose them right from the highest quantum level first. So if we want to say form iron 3+, we'd have a condensed electron configuration of argon, and we need to lose 3 electrons, so we would lose 2 electrons here from our highest quantum level first, and then we would need to lose 1 electron from our d orbital. So at the end of the day, iron 3+ would have an electron configuration of 3d5. We lost 2 electrons here, followed by 1 electron from the d orbitals, right? So iron could obtain this Nd5 configuration. The two other cases we can look at are iridium and rhenium. So rhenium, electron configuration of xenon 6s2 4f14 5d5. And again, right, we can form an ion. We're going to lose electrons from our highest quantum level first. So if we form rhenium 2+, our highest quantum level is 6s. So we lose those 2 electrons here, and we'll be left with 4f14 5d5. Again, giving us the requested ion configuration for our d orbitals for rhenium if we form a 2+ ion. The other case we can look at is iridium. Iridium is just 2 elements over from rhenium, so it's going to have 2 more electrons, so 6s2 4f14 5d7. And sure, if we lose 4 electrons to form iridium 4+, right, we're going to lose them from our highest quantum level first, so we'll lose 2 electrons here, followed by 2 more electrons at our next highest quantum level, which is the 5d. So our condensed configuration for iridium 4+ would be xenon. We lost the s electrons, so it would be 4f14, followed by 5d5, again, meeting that requirement of Nd5 configuration. The remaining 3 that don't work, yttrium, radium, and protactinium, I'll show you why those don't work. And yttrium, for example, its electron configuration is krypton 5s2 4d1, right? So we do not have enough electrons to form a cation with a terminal configuration of Nd5, right? We have less than that number of electrons, so we can't lose any to obtain that. And our metals aren't going to gain a negative oxidation state. This metal is not going to gain ions to form that. So yttrium won't work. Take a look at radon, which is a noble element, to see that its electron configuration is xenon 6s2 4f14 5d10 and then 6p6. So this case, we have more than enough electrons. We've got beyond that, but in this case, a noble element configuration, noble gases, noble elements do not want to lose electrons. And we can kind of see why It'd be really hard for radon to take an oxidation state of Nd5 because we need to lose from our highest quantum level first. We'd have to lose 6 electrons here plus 2 electrons here. That's 8 electrons. And then to get to our Nd5 configuration, we have to lose 5 more electrons here for a total of 13 electrons. It's just not going to happen. Radon's not going to give up that many electrons. So again, it can't form an ion with that electron configuration. And in the last case, protactinium, we'd see that we've got electron configuration of radon 7s2, 5f2, 6d1. And so again, in this case, we don't have enough d electrons to take us to Nd5, so we certainly can't form a positively charged ion with that final configuration. So that's what we're looking for. We're looking for what's the neutral atom's electron configuration. Do we have enough electrons to bring us past this point for the neutral atom, so that when we go to form our cation and we lose electrons, are we able to obtain that final electron configuration that we're asked for? And then the key to remember, right, is that when we're going to form a cation with a transition metal, we're going to lose an electron from our highest quantum level first. So what's our highest quantum level? In this case, it's 4. 4 is greater than 3. So we would lose these electrons before we would lose electrons from the 3d orbital. So I hope that clears up any questions anyone had on 7.48.